CIT 1121, Module 11, Submodule 6, 7, and 8. Subnet a /16 and a /8 prefix. We actually did this in the last module, but we'll take a quick look at it again. When we are subnetting something with a /8, we're going to have a whole lot of addresses. And the number that's going to change when we subnet is going to be in the second octet in the subnet mask. The diagram that we see here is with the /16 and then beyond. And you can see, just like we did in the last slide, instead of it being, a 25 or 26 like we were doing there, they're doing 17, 18, 19, 20. It's the exact same thing. The number of total hosts is halved every time you take a binary digit in the IP address and move it from host to network. It will change, and it will reduce the number of hosts by half. So you can see there, a slash in 16 is not written across here, but a /16 is 65,565 total hosts. When we go to /17, we cut that in half, 32,000. When we go to /18, we take 32, cut it in half, 16, 19. /19 is going to cut down to 8,000, so on and so forth. And it's going to get all the way down to where you get to /24, where you're totally out of the third octet altogether, and then you're into just the fourth octet value. So we're back at the dot right there at that /24 when you get into this position right here. So that's all they're getting into here is creating subnets like that. And they're just showing you how the mask value is going to change, and it goes up. And it goes from 0 to 128 to 192 to 224, 240, 248, 252, 254, 255. This is the progression that it's always going to take because the highest order bit in any byte is worth 128, right? So the highest order bit. And then if we're going to change the highest order bit and then the second bit, or the second highest order bit, the seventh bit, into network instead of host, you're going to change that value to 192. And if you go to the first three, because 192 is 128 plus 64. Add 32 to that, and then you get to 224. Add 16 to that, and that'll take you to 240. And just you can see what's going on. You're just taking the bits that used to be zeros in the subnet mask. You're making them ones, and what does it do? It shrinks the space that you have to create giant networks, and it makes it smaller. So if we have smaller space to create a network, that means that we're using less bits. That's all they're getting into in this slide. All right. The next thing we get into is 11.7, and that's subnet to meet requirements. All they're talking about here is a couple of things. Number one, you want to be able to build subnet masks, and you're going to use a mask that's going to make the subnet around the size of the number of addresses that you actually need. Now, there's a couple of rules that you go along with that. Number one is, if it's smaller than a /24, that's okay. We may have to subnet down and do 5 addresses, a network for 5 addresses, or a network for 2 addresses. If it's a point-to-point network, we're going to use a smaller mask because we only have so many addresses that we can work with. The other piece is this, and this is where they kind of, they're showing a diagram here, and they're like, very smartly use your private space versus your public space. All right, this router here in the middle is going to perform what's called network address translation. Now, we saw that before. All of our devices here are going to be on a private address space. This is going to be 10.something, or 172.16.something, or 192.168.something.something. This is all going to be private space. Always, always, always. All your devices, they're going to NAT their way out to the internet so they can have access to the internet. So we're going to utilize the public IP addresses that our internet service provider has leased to us. Now, stuff that's in the DMZ zone, these are going to have public IPs as well. And they're going to have public IPs, and they're in the zone called the DMZ, the demilitarized zone, because you're going to have devices that are out here that want to gain access into these services. And they're going to have to pass through this router. Now, you don't want these guys getting directly over into your production network. You just want them to utilize the services that they're supposed to use from the internet. And that's where these guys come in. So they're going to need public IP addresses. So if you have your own email server on site, it's going to need its own public IP address. If you have a DNS server or you have a media server, and you have backups of those media servers, you're going to need a public IP address for each one of those things. So your internet service provider is going to provide you with IP addressing space that's about the size of addresses that you need. So when you go to your ISP, they're going to say, how many public IP addresses do you need? And you'll say, I need 4. They'll be like, that's great. We'll give you a /29, because in a /29, there's 8 addresses total. And the first one is a network ID, and the last one is a broadcast ID. So you can't use those. That leaves us 6. And the internet service provider is going to be like, well, you're going to contact us on that network, so we'll take 1. That would leave you with 5. That's fine. That's great. And that's a pretty standard thing for a smaller business. But if you have a lot of servers, you're going to have to lease a lot of addresses. It's going to cost you a couple of bucks. Just be aware of that. And that's all they're getting into in this particular slide. Okay, next slide. Next slide gets into minimize using host values. And this is just /25 through /30, which we've already talked about. And you can see how the network is taking over. The network is taking 1 bit in the 4th octet in that first line, and then 2, and then 3, and then 4, and then 5, and then all the way down to 6. Every time another bit is borrowed and given to the network, it creates twice as many networks, because there's twice as many combinations of 0s and 1s that are set for n in this space, and the number of addresses goes down. So the number of networks goes up, but the number of addresses actually goes down. And that's the thing about subnetting. And this is fine. What we're trying to do is match this size with the size of the actual networks that we have. Now, the thing is, we can't make a perfect match all the time. Like I said, you might need 4 public IP addresses. Well, you can't get a subnet. You can't get a subnet that's just going to give you 4. You're going to have, well, you can, but you can't use 2 of them. So you can't have 4 usable addresses. You can have 2 usable addresses with a /30, or you can have 6 usable addresses with a /29. Well, 2's not enough. 14's really way too many. 6 is the best answer if you need 4 or 5. So sometimes it doesn't fit totally, but it'll be close enough. So just keep that in mind. And the reason it doesn't fit totally is because the binary translation into decimal doesn't equal an exact, 1. I want to make a subnet that's 26 value. No, you can't. It's 2, it's 4, it's 8, it's 16, it's 32, it's 64, it's 128, it's 256, it's 512, it's 1024, it's 240, 2048. Those are the sizes of networks that you can have. You can't customize to an exact size. Okay, so keep that in mind. And that's all they're talking about here is, I need, 50 addresses. Okay, well then let's make that a /26 because 50 will fit into that, and because it'll give you 64 total addresses, and that's fine. The next thing they get into is VLSM, which just stands for Variable Length Subnet Masking. This is nothing more than what we've been doing. When you see that CIDR notation, that /24, /25, that connotates, that's definitely VLSM, okay? That just means that we're not going to follow some of the rules that we had for classful networking. The rules for classful networking are as follows. If a number is in a class A, like it starts with the number 1 through 126, then the default subnet mask is 8. And we can't make it any shorter than 8. Well, also, if we have a Class C address, which is anything that starts with the first number between 192 and 223, the default subnet mask for that is a /24, and we can't use a mask that's like a /16 or a /8 or a /7. It has to be no more. So variable length subnet masking took that rule and said we're not going to use that anymore. We're just see the mask, look at the mask, whatever it is, /24, great. The first 24 digits are for network. /17, the first 17 digits in the address are set for network. Whatever's left is host. So VLSM is actually simpler than the classful system that we had previously. It's just look at the mask and apply the mask to the system. It'll tell you how many addresses are in a given subnet. Okay, so that's what they're getting to in that particular slide. The next couple slides just go through a very simple exercise, and it says, hey, we've got 7 networks. And on those 7 networks, if this was a classful system, we wouldn't be able to variably subnet into that space. And that's another problem with it. So we would say, all right, well, what's the biggest network that we have? The biggest network we have is 28. So every network that we subnet out has to have at least 28 hosts. And if we have to have at least 28 hosts, that means we're going to do networks that are 32 total addresses big or 30 usable addresses, because that'll support 28. And they put the first one here. They said, you know what, addresses 0 through 31, we're going to put them here. And the next block of 32 addresses, we're going to put here from 32 to 63. And the next block, we're going to put here from 64 to 95. And the next block, and I drew a circle over it. You can't see it, but trust me. Then this one, it's 96 to 127. And then they went to the bottom, and they said, okay, well, this one, even though it's only 2 hosts, we're going to use 128 through 159. And then this one, we're going to use 160 through 191. And then this one, we're going to use 192 through 223. And it's supported and it all works. But we just used 224 total addresses. We just used 0 through 224 to support these 7 networks. Now, one of the things we said about IPv4 addressing is we want to make the networks the size that fits best. So in the next slide, we go, all right, we're going to use variable length subnet masking this time. We're going to do the same thing across the top for the most part, but across the bottom where we have the 2 hosts, we only need 2 hosts, we're actually going to change the mask. So the top looks pretty much the same. We go, oh, okay, well, we got 0 through, we have a /27, so this one's going to be 0 to 31. And then this one is 32 to 63. And then this one is going to be 64 to 95. And this one's 96 through 127. And we used we did exactly the same thing as we did before. Could we have made it a little smaller? No, not really, because even this one that's 15, if we shrunk that network size down to 16, that's really only 14 usable hosts. So they kind of almost did a little trick job on us there. Each one of these would need at least 32 addresses, because 16 total or 14 usable doesn't fit for any of these. So we just use those bigger ones first. Now, we've used the first 128 addresses. Now, how about down below? Now, what they say here is, hey, let's do this. Let's not use. I don't know why they didn't go to 128 here, but they started way further up the chain. So we're just going to use 4 total 2 usable addresses for each one of these networks, which gives us a /30. So this one's like 224 to 227. This one is 228 to 231. This one is 232 to 235. And we're using a whole lot less addresses this time. So we had 128 total addresses across the top. And then across the bottom, it's another 12 more. So 224 through 235, which is 12 addresses. So 128 plus 12 is 140. So now we're only using 140 addresses, where in the last example, we were using over 220. So we just saved 80 addresses by trimming down these point-to-point networks into these /30 systems, okay? So, and there's a lot of addresses we can still use. Anything between 128, and this time, anything between 128 in the 4th octet and 223 is still open. It's still available. We can use it someplace else. The main thing is you can't overlap any of the address space, and you can't definitely make the network exactly the size that you need. It just has to figure out which size will fit best, and then you use those. Okay. The last piece is structure design. Let's just take a look at. There's 2 more slides in here. As far as network planning goes, the most important thing is, once again, not overlapping your address space. 2, putting your networks the size that you want. 3, when you have multiple sizes of networks, when you have a lot of different sizes of networks, allocate the biggest networks first. And it's just a trick that you can use. It'll just make life easier because what will happen is the bigger networks will always take up the space of multiple smaller networks. So, for instance, 0 through 255 is a /24 network size. There are 2 /25s that fit into that /24. 0 through 127 and 128 through 255 gives you 2 networks that make up that 1 /24. So if you ever allocate address space, always just allocate the largest network first. Always allocate the largest network first. And then this is just saying, hey, by the way, there's different kinds of devices that you're going to set up. And some of them are going to need public IP addresses. Some are going to need privates. Some of them are going to be DHCP clients. Some of them are going to be statically configured. Just be aware of that and getting into that. Like, so for instance, a router gateway should always be statically configured. A printer, in most cases, should be statically configured. A host that joins a network and just wants to surf the internet, I don't care what his IP address is. There's no service that any other device is using. That would be a good example of something you would set up for a DHCP client. All right?